Hey everyone, Jason here at Evo Technology, and in this video I want to introduce a new tool that we just released for the Arduino IDE that allows you to program or update the image on the FPGA for our Evo M51 board using the GUI in the Arduino IDE. Now this is something that you can do with the command line, or pretty much from very early on with this new board, we've had a command line tool that allows you to flash a new image onto the FPGA and right across the USB connection, so you don't have to have JTAG or anything like that. A tool or a capability that we have for all of our hardware, all of our FPGA-based boards. But because Evo is slightly different than our other boards in terms of the kind of design it has and how we've integrated the microcontroller, the tool to do that works a little bit differently too. And originally we just had the command line to do it, which still makes it pretty easy. But now we have a GUI tool that you can just use with the Arduino IDE. Makes it even easier, and I wanted to show you that in this video in case it's something you're interested in using. And as we continue to release Evo images that we prepare, it'll make it really easy to flash those, or if you're doing your own designs, your own images for the FPGA using our Open Evo methodology, it allows you to do that with the GUI also. So what I want to do is show you how to go grab that tool, how to set it up so that it can run in the Arduino IDE, and we'll show you trying it. Now in order to demonstrate this, what I'm going to be using today is I've got an Evo M51 sitting here. Hopefully the focus is okay. I was having some trouble with that, but it's sitting on what we call our servo tray board. Servo tray is a carrier board we designed that breaks out a bunch of I/O specifically for controlling servos. In this particular case, we can have 32 servos being controlled in parallel. All that control is happening on the FPGA fabric. So very, very precise, very deterministic, great solution for controlling a lot of servos in parallel. We can talk a lot more about that at another time in another video, but that's the platform and that's the Evo M51 I'm going to be using to demonstrate this. The first thing we want to do is we want to go to GitHub and actually grab the tool because that's where we are hosting it. I'll grab my glasses here. Okay, so what we want to do is go to github.com/Evo Technology, and I'm sitting there on that page right now, and you can look, it's right up at the top because it's one of the most recent things that we updated that Brian did. So we're going to click on this Evo Flashload GUI, and that'll take us to that page. And from here, we're just going to simply download the zip file. So I'll click download zip, and I'm on a Mac here, so this is going to dump this into my downloads directory. And what I want to do is I'm going to shift over to a different desktop because I've got this all set up. So here it is sitting here in my downloads directory right now. And I'm going to open that up right in here. And just for the record, no, my downloads directory does never, ever looks this clean. I hid everything just for making this video. It's usually full of all kinds of stuff, just like most people. Now, if we look down in the GUI Flashload, what we're going to see is it's got this tools directory hidden in here. And then down in there is the tool itself. There's kind of this nested tools thing going on. It's just sort of the nature of adding a tool to an Arduino that we need to do this. This Evo Flashload jar file, that's really the thing that adds the GUI option when you load and run Arduino. But what we want to do is this is the directory we care about, this tools directory. And where we want to put this is in your standard Arduino where you're working on your sketches, where you're working on your program files, kind of your local development folder. For most people, that's generally, if you're on a Mac, I think this is true also on Windows. I generally do my work on a Mac. It'll be in Documents here, and then Arduino. And once you're in there, you've got Documents, Arduino. This is where you tend to see all of your directories for sketches, programs, applications you've been working on. Now, again, I have a really short list here because this is a brand new machine, and most of the development work I've done over the last number of years is all still sitting on my other laptop. I didn't try to bring everything over. So again, really clean directory, easy to look at. And you can see I already have a tools directory here because I was doing some testing. Let me get rid of that. Because if you don't have a tool that you've added on, you won't have that directory. So you can see I have the libraries directory, which gets installed by default with Arduino, and then any programs you've been working on, that's where these are going to live. So what we want to do is just grab this tools directory. And remember, we want to grab the top level one here, and we're just going to pull it right into the Arduino directory. Now, once we've done that, we'll have tools, Evo Flashload, some README information stuff, and this whole hierarchy will still exist, and that's exactly what we want. So let's go back to my other desktop now, and we will start the Arduino tool. And what we should see when we start that then is we should see that we have an option to run the tool from the command or the tools dropdown. So we click on tools and here it is. So Evo Flashload has now been installed and we can run that tool. Now what I want to do is I want to make sure I have my Evo plugged in. So I'm going to do that real quick. Okay. Now, once that's plugged in, we'll make sure that we're seeing it here. So we've got it selected. Okay, we've got the port selected. And we'll run Evo Flashload. Let me hide this back here. We don't need that in the mess. Okay. So what this is going to do is it'll bring up this tool. I'll hide that too, make it even cleaner. Now here's what the GUI interface looks like. It's got the instructions on there that we just went through, made sure we're connected, we've got the right port, we've got the board selected, and now we want to choose our image. And we've got these 4 buttons sitting here. And the first 2 are basically images that are delivered as part of our boards package. The R0487 is what we call our legacy Evo image. That's the very first image we released with the board when we started producing them last year. And then R0573, that is the latest, most stable version of the Evo image that we encourage people to update to right away as soon as you get an Evo board or when you're ready to make sure you have the latest and greatest. That's the one. And those ship with our boards package that comes with Arduino. We'll jump down to the bottom here, this Browse for Image button. This allows you to select an Evo image that you may already have. Maybe sometimes we supply images to our customers if we're helping them deliver or helping them develop stuff for their boards. Or you've created your own and you can browse for it and just choose the image you want. And then you'll see this grayed out button here which says Open Evo Image. And what that is the image that gets generated if you are following our Open Evo methodology, which is essentially the way that you can develop your own custom images for Evo M51. We've got documentation and webinar kind of tutorial stuff out on our YouTube channel that you can check out for that. And so that if you want to learn about Open Evo, I'll tell you where that is, and you can find a link to it in the description for this video as well. So that's what that one's for. But what we're going to do right now is we're just going to update to the latest stable Evo image. So all we need to do, let me bring up the Arduino again because you'll be able to see the messages scrolling by when I do this. We're going to click Evo default image. And you'll see back here, it's actually running that command line for us that we would normally run. So the command line you see in the background there is something you can run as well. If you prefer to work out of a terminal or you prefer to do command line, you can do that. Now, this takes a few minutes to go through the process. And so kind of once we see that it's going forward, I'm just going to jump ahead in time so we don't waste a lot of time just watching. But you'll know things are starting to operate. You'll see beginning Evo Flashload. This may take a few minutes. Programming Evo SAMD. So what it's doing is it's actually uploading kind of a helper program that helps pass the image through the SAMD into the FPGA. And you'll know things are working correctly when you start to see this finished A page 200, 300, 400. And it probably doesn't come as any surprise that it's going to count all the way up to 2944. This is the part I'm not going to make you watch to its completion because it just takes a couple of minutes here. So we'll see you as soon as it's programmed. All right, now once it is done, you'll see here that it says finishing 2944 of 2944. So the FPGA image load is done. Now what it's going to do is it's going to reload our Get Evo Info program so we can kick out and see what kind of information is in there. And if we look down here, we can see this is indeed the SVN 573. So that's exactly what we wanted to load into the FPGA. So hey, it all worked great. Now again, if we wanted to do our own custom image, obviously this probably isn't going to seem like too much of a surprise, but just to show you, we can click on Browse for Image and we'll grab this other GUI will pop up. And what I want to do is go to Documents, Arduino, and down here I'm going to go into our ZBus directory. ZBus is the high-speed interface we have between the FPGA and the SAMD51 that allows us to take advantage of the DMA on the SAMD side and also be able to take advantage of the parallel capture controller on the SAMD side to be able to send data back and forth between the FPGA and the SAMD which a lot higher data rates and in parallel. And that's something that we're working on releasing as well. We have some customers that definitely want to be able to do that. So we've been playing around with that. So I've got an image sitting here. Now you'll see that the extension on that image is .evo_img. So that's what this tool is looking for. So we can just grab that. We click open. And if we look down below here in the messages area in Arduino, again, we're going to see that command line. And once again, it will go through the entire process of uploading that new image. So that's kind of it with this tool. I think this makes it really simple for you to be able to update the image on your FPGA with your Evo M51 board if you prefer not to use the command line. And again, as we release images that we have from our designs that we want to provide, just make it easily accessible for you to use, they'll show up in the boards package, and they'll automatically, this tool will automatically scan that directory and add any image that we've provided to those buttons so you know what it is and you can update it. We can see down here below now it's saying finishing a page, so far so good on this. While this is finishing, I'll encourage you that if you want to learn more about Evo M51, we talked a little bit about the Open Evo process. You can go to our YouTube channel. It's youtube.com/aloriumtech. And while you're there, you can scroll down. You can see right here under Evo, there's some advanced technique tutorials for the Open Evo methodology and the quick start. Our head engineer, our lead FPGA designer, Steve Phillips, has done a really great job on these in terms of stepping you through the process on how to get these things updated or how to get familiar with this methodology and start generating your own images for the FPGA. And keep in mind that when you do this, you don't need any kind of JTAG programmer. You don't need any special hardware. You will have to use Quartus Prime Lite from Intel to do the FPGA synthesis, but it's all scripted and set up for you, so it's very easy. And you can use the Prime Lite version, which is free, so it doesn't cost you any money. We've tried to make it as easy as possible for you to be able to just understand how to integrate your own hardware into the FPGA and run it through all the steps required to program it and start using that new design. So let's take one quick look here and see if we're done. Oh, we're getting close. We'll let it finish off here, and if we get a good output from Get Evo Info, then we'll be satisfied that, hey, everything's working, even loading this custom image. Now, one of the things that we maybe didn't completely fill in with this custom image is some of the registers with information on it. So here we can see 468, so that changed. I don't know what it's actually supposed to be for this image because this is a work in process. So that may be right, it may be not. It's not something we've released, and I'm not really sure what the SVN tag was for that. So maybe it is. It was just kind of a work in process, but it has changed. So we did get a new image update in there. So it's all working. All right, well, that is it for this video. I hope this helps you understand how to implement this tool. If you have any other questions, by all means, shoot us an email at support@aloriumtech.com. That hits our team. A lot of the core developers here that are working on this stuff, including Brian, who did this cool update to the tool for the GUI, and Steve, our lead designer, I'll be on that. So we tend to respond really quickly. If you have any questions or want any support or want to learn anything else or see anything else, please let us know. Again, thanks for watching, and we'll talk to you very soon.